Hello, welcome to Unit 5 on trigonometry. Today's lesson 1, trigonometric ratios of acute angles. Some of this will be review, some of this will be brand new stuff for us. But let's get going. So we need to remember Pythagorean theorem, only used in right triangles. A and B are called the legs, and C is called the hypotenuse. Okay, and we need to remember that the hypotenuse is always the longest side. Okay, so it's across from the 90 degree. That box represents 90 degrees, so this is the hypotenuse. Okay, Pythagorean theorem, a squared plus b squared equals c squared. Okay, it means the same thing as c is the square root of a squared plus b squared. And we should also remember, if we know the hypotenuse, so we're looking for an unknown leg, we can do b squared is c squared minus a squared. Okay, we also learned in grade 10 three primary trigonometric ratios. Those were sine, cosine, and tangent. And they could be remembered using SOHCAHTOA. And remember, SOHCAHTOA is an acronym that tells you the order of things to do. So with the sine button, you're doing opposite over hypotenuse. Again, the primary trig ratios can only be used for right triangles. Okay, so as I just mentioned with the acronym, sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tan is the opposite over the adjacent. Okay, then we will also, we'll look at this, it's the new part of the unit, and that is reciprocal trig ratios. So if you remember to the last unit, reciprocal means flipped upside down, so the opposite. And these are the reciprocals of sine, cosine, and tangent. So the reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. And just like the primary trig ratios, these can only be used on right triangles. Okay, and so we have cosecant theta. It's actually 1 over sine theta, but that also means instead of opposite over hypotenuse, it's hypotenuse over opposite. Okay, secant theta is 1 over cos. And again, we flip upside down, so this is hypotenuse divided by adjacent. And we have cotangent theta is 1 over tangent, or adjacent over opposite. Okay, and if you don't remember from grade 10, so what do we mean by these words hypotenuse, opposite, adjacent? If our reference angle is at the top here, top left corner, the opposite will be opposite of our reference angle. The adjacent touches the reference angle, and as we already learned, the hypotenuse is across from the 90. If our reference angle is in the bottom right corner, hypotenuse is the one that does not change. But now our opposite is over here. on the left side, and the adjacent is at the bottom. Okay, in each of these ratios, there are 3 unknown values, but only one can be missing for us to use it. There are 3 possible unknown values for us to solve for in a question. So side length on top. So we're looking for side length and your variables on top of your fraction. So an example would be sine 37 equals x over 21. And in this case, because the variable's on top, you're going to multiply the sine 37 by the denominator. Okay, so variable on top, you're multiplying your two numbers, sine 37 times 21. If we're looking for a side length, but the variable's on the bottom, so if we do cos 81 equals 15 over x, okay, you're going to swap the cos 81 and the x, so this actually becomes x equals 15 divided by cos 81. Okay, and if you're looking for an angle, we're using inverse functions. Okay, you learned about this as well in grade 10. So if we have tan theta equals 5 over 8, the angle is tan inverse of 5 over 8. If you're on an iPhone, you'll press the second button to get to the inverse. If you're on a regular calculator, you'll press shift. Okay, so some examples. Side length on top. So here's our reference angle. We need to first label the triangle. We know that the longest side is the hypotenuse, and the side that touches your angle is the adjacent. This question has nothing to do with the opposite. So if I write SOHCAHTOA on the top of my page, you can see that Ka is the only one that does not have an O. So it's the only one where opposite is irrelevant. So we are using cos theta, which is adjacent over hypotenuse. Okay, theta represents angle, so we have cos 41 equals x over 13. And as we know, when the variable's on top, we're going to multiply, so it's 13 times the cos of 41. So x equals 9.8. And I'm skipping a step there because it's more accurate when you use all the decimal places. Okay, cos 41 rounds to 0.755, but that's not the most accurate answer. So just press cos 41 and then times 13. Okay, side length on the bottom. Our reference angle is down here, the 26. So the 15 would be the opposite because it's opposite, and the x is the hypotenuse. So this time we're using O and H, so that means we're going to use sine. So sine theta is 15 over x. So we get sine 26 equals 15 over x. Sorry, back here I should say opposite over hypotenuse. My mistake. Okay, and through our last note above, we know that we can swap the x and the sine 26. 15 divided by sine 26, we get 34.2 centimeters. Okay, and then the angle, so our reference angle is there. We label the triangle, so opposite the reference angle is opposite. Touching the reference angle but not the longest side is the adjacent. The only one of SOHCAHTOA that's OA is tan. So we're using tan theta is opposite over adjacent. Okay, we don't know the angle here, so we're looking at tan x equals 11 over 15. It's an angle, so we're using inverse of 11 over 15. So this you can do on a calculator, tan inverse, and then bracket 11 divided by 15. On an iPhone, 11 divided by 15, hit equals, then press tan inverse, and we get an answer of 36 degrees. You always want to round to the nearest degree when it's angles. Okay, in triangle ABC, so we know with this lesson we're talking about right angled triangles. The side lengths are 3, 4, and 5. A is 3, so remember the matching pair, the corresponding angle and sides are across from each other. So if angle A is at the top, side A is at the bottom. C is 90 degrees. Which trig ratio of A is greatest? So we can label the triangle right away because we know that 3 is a leg, and we know that the hypotenuse has to be the longest side. It gives us all the measurements, so we can infer that the hypotenuse is 5 and the other leg is 4. Okay, so it wants the trig, which of the trig ratios is the greatest? So we're going to work with sine, cos, and tan, as well as cosecant, secant, and cotangent. Okay, so we have sine theta, cos theta, tan theta, and then we'll have cosecant theta, secant theta, cotan. Okay, and it's telling us to work with angle A. So with sine, we know we're doing opposite over hypotenuse. The opposite here is 3. The hypotenuse is 5. Cos is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, for our reciprocals, so you don't even need to look at the triangle here. You're just flipping them upside down. Cosecant goes with sine, so you just flip it upside down. Secant goes with cos, so you flip it upside down. And cotangent goes with tangent, flip it upside down. Okay, now we can look at all of these and see which one is actually the greatest ratio, and that is cosecant. 5 over 3 would give you a larger decimal than the other 5 ratios. Okay, in sine theta equals 2/3, what are the other 5 trigonometric ratios? So this time, it's giving us 2 pieces of information. Okay, if we're working with this angle up here, sine is opposite and hypotenuse. So we know that the opposite will be 2, the hypotenuse will be 3. In order to find the third leg, this is where Pythagorean theorem comes into place. Okay, so we know the hypotenuse here. So let's figure out the other leg. It will be b squared equals c squared minus a squared. Okay, so we get 9 minus 4. So b squared equals 5. And we want to know what b is. So b will be the square root of 5. Because you can't just square root 5, we're going to leave it here as the exact answer. Okay, it gave us sine, so let's work with the other. So the other 5, so sine was 2 over 3. Cos and tan. So cos from that top angle is adjacent over hypotenuse, and tan is opposite over adjacent. And then we have cosecant, secant, cotangent. So again, we're just flipping those reciprocals upside down. And those are the other 5. Okay, almost done here. Evaluate to 4 decimal places. So tan 68, you're literally just typing in tan 68 here, and you would get 2.4751. Cotangent 35, cotangent is not a button on your calculator, so you need to work with the reciprocal. So this is actually 1 over tan 35. So you do 1 divided by tan 35, you get 1.4281. And same with cosecant, so we know cosecant is the reciprocal of sine. So this is 1 over sine 10, which is 5.7587. Okay, working with the inverse. So this time it's giving us the decimal. We want to find the angle. So we're going to cos inverse here, 0.2654. And the angle is 75 degrees. Okay, same here. We're going to tan inverse 1.2601. We get 52 degrees. Okay, secant we know is the reciprocal of cos. So, and we have to work with the reciprocal, so it's actually the cos inverse of 1 over 3.5946. And you get 74 degrees. And again, cosecant is the reciprocal of sine. So this will be the sine inverse of 1 over 4.4444. So the angle here is 13 degrees. Okay, that's just something you'll get used to. Okay, last piece, solve the triangle. So here we have our reference angle. First thing we can do though is find out the other angle, right? We have two, a 30 and a 90. We know that all three angles add up to 180. So let's work with angle A is 180 minus 90 minus 30. And that equals 60 degrees. So A is 60 here. Okay. We know this is our hypotenuse. If we're working with 30, this is our adjacent. This is our opposite. So we can use SOHCAHTOA to figure out H and A. So for side A, which is the bottom here because it's across from angle A, this would be side C. So working with side A, it's adjacent and opposite because we're working with that angle 30. Adjacent and opposite work with tan, so it's tan 30 equals opposite over adjacent. Variables on the bottom, so A will be 10 divided by tan 30. So angle A is side A is 17.3 centimeters. Okay, and then we have side C. Multiple ways you can do this. You can work with angle 30, you can work with angle 60, you can even do Pythagorean theorem now that you know the other two legs. But we're going to stick with the angle 30. Okay, now it's opposite and hypotenuse. So we're working sine 30 equals opposite over side C, hypotenuse. Again, variables on the bottom, so it's 10 divided by sine 30. So side length C is 20 centimeters, which is greater than the other two, so we know that this works.